So hi friends, welcome back to my channel Engineering Chronicles of Plant Design. So in today's video we're going to see about design and fabrication of pressure vessel. That those will be mostly as per ASME section at division 1. Okay, so here in this video it may be of various 3-4 parts. I'm not sure, but we will cover all the requirement of how to design a pressure vessel. Okay, so before we go ahead with any of the uh, pressure vessel design or anything, you need to know what is ASME and why ASME has formed. So ASME is American Society of Mechanical Engineers. So what happened in late 1800? What happened is there was so much of power boilers. Power boilers means there are different kind of boilers. So if we have a boiler from which we are only generating power, electricity, so those boiler are called power boiler. And if we are using a boiler for heating purpose for a process plant, so those boilers are called heating boilers. Okay, so we will see there are different provisions in code also. But in 1800s, what happened in late 1800? In USA, there was so much of power boilers designed and installed in different part of USA. But suddenly, what happened after installation? There were too much of incidents. Around 2000 boiler had gone explosion. So people stopped working and they said that we will not go for work. Money is not important, life is important always. So in that case they stopped working, and the government thought why how to to bring why this has happened. So they formed a community and they formed a unit where they start investigating, and they found that there was a faulty design, faulty inspection method was used. So then they were, they national board, which is called NB. So National Board of USA, they formed a community, and they said you make a something, code, a standard, which will be used to design a pressure vessel. So ASME in 1911, they have given the first volume. Sorry, in 1911 ASME was formed, and the first volume for the pressure vessel BPV, see boiler and pressure vessel construction, was 114-page volume, which was published in 1915. Okay, and over the years, now there are some different codes, different standards. Now we have Division A, Division B, Division A for major fabrication, Division B for all pipings and piping assemblies and fittings and all. So now ASME has involved in a big community. It is a non-profitable organization actually. So and they have different standards. Okay, so different standards means you see here. So different section. So as I said, there are two division. Division A, which is having all the section 2, 13 section, and we have division B, which is mainly involved with the piping. So in division A, we have section 1, which is power boilers. As I said, the boiler which is used only to generate power is called power boiler. Section 2. Now section 2 is very important because whatever you do design in section, let it be section 8 or 1 or 4, so you will find all the design data in section 2. Okay, so it is called material specifications. Section 3, nuclear components. Section 4, heating boilers. So this where you use the boiler only specifically for process plant for heating, for use for heating. Okay, that is a heating boilers. Then section 5. Section 5 is mainly for the inspectors, which is non-destructive examination. It is a bunch of instruction given to the inspector how to how to do inspection, and what are the criteria requirement and all this thing. Then section 7, recommended guidelines for care of power boiler. Sorry, I missed section 6. So section 6 is first, recommended rules for care of operation of heating boilers. So and section 8 is recommended guideline for the care of power boilers. Okay, section, if you have section 1, so you need to go with section 7 for the guidelines for the care of power boilers. Same goes with 4. You have to again go with section 6 for the rules and of the operation, okay, of a heating boiler. So now we will focus only on unfired pressure vessel, section 8, ASME section 8. So in ASME section 8, there are three divisions, like division 1, 2, and 3. So 1 is a rule of pressure vessel, 2 is an alternative rule. We will see later what is different between 1 and 2. And 3 is a high pressure vessel design. Okay, so we will only concentrate on section 1, section 8 and division 1. Sorry. Okay, So section 9 is deals with the brazing and welding details. How, what is the category and what are the details required for welding and brazing or fusing. Okay. Section 10 deals with the fiber reinforced plastic pressure vessel. Section 11 rules for in-service inspection of nuclear power plant components. Section 12 construction and of continued service and of transport tanks. And section 13 rules for overpressure protection. Okay. So as I said, there are three in section. We are going to see ASME section 8. Okay. In section 8 we have three divisions: division 1, division 2, and division 3. So division 1. So you might say what is the criteria, for pressure vessel? What is the design pressure criteria? So it is starting from 15 psi Pascal square inch to 3000 psi. Till that range you can apply division 1, and this design is mainly by rule approach. Okay. But division 2 we have same pressure range. It is not like the high pressure above 3000 psi we have to go with section 2, but pressure range is same as at division 1. But here the difference is, the design is by analysis approach. Here you have to focus on the finite element analysis of a pressure vessel. Okay. So there are some appendix which which you can apply the division 2 formula in division 1. Those applications are there. But mainly what we do is, whenever we design a pressure vessel, we go with the division 1 formula only. Sometime in some cases, yeah, if you want to save a little more money on the thickness, so yes, we go with division 2. But then there are some design criteria, appendix 46, which is there, mandatory appendix, based on which you can use division 2 formulas for division 1. And division 3 is for high pressure vessel above the pressure range of 1 and 2. The whatever pressure vessel is designed will be as per division 3. So let's see what is the scope which is applicable in section 8 division 1. So you may say, like, if you have a piping apart from pressure vessel, will that fall in ASME section division 1? No, it will not fall. No, there are the limitations where the code says, though, so we have to go with that limitations as well. So let's go one by one. So component falling within the scope of applicability of other sections. For example, you are using section 1 and you want to use section 8 design. So that is not possible. Okay. So second is fire process tubular heaters. If you're having a heater which, and inside you have a fire process, so no, that will not fall under section 8 division 1. Rotating or reciprocating mechanical devices like pumps or compressor, no, it will not fall under section 8 division 1. Piping system and piping components, hot water supply storage tanks, and vessel whose internal or external pressure rating does not exceed 15 psi. But here we say does not exceed 15 psi, but there are option where we use vacuum. But when we use vacuum, what we do is we apply external pressure. For example, vacuum is something, the pressure inside the vessel will be nil. Okay, there will be no pressure. But what will happen? The atmospheric pressure on the wall of the pressure vessel will act as an external force. So we apply as an external pressure rating. But yes, it is possible. But sometime, in some cases, we say, if the pressure does not exceed 15 psi, we may not design it under section division 1. But possibility is there. Okay. So one more thing is the size of vessel. If the diameter of the vessel is not more than 6 inch, it is not as per, we cannot design the pressure vessel as per section division 1. Okay, this is the minimum size requirement for a as per section division 1. So next is pressure vessel for human occupancy. So what is human occupancy pressure vessel? So you may know, there are submarines which go inside the water of no you know in a underwater. The people go inside the submarine and they go underwater. So those kind of pressure vessel does not fall under section 8 division 1. But you can design as per section 8 division 2 with some the different approach. But yes, division 2 it is possible, division 1 it is not possible. So moving ahead, what does this code contains? So section at division 1, what does it contain? So it is mainly divided into three subsection: subsection A, subsection B, and subsection 3. And apart from that, we have mandatory appendix and we have non-mandatory appendix. So subsection A is called general requirement. We say UG, since it's a U stamp. A section A division is a U stamp pressure vessel, so we say U. So if you go to U2 stamp, that is section 2, so you will say U2G, U2G1, U2G2, it will come like that. Okay, and in section division 3, it will be U2, U3G, U3G1, all this subsection will be there. Okay, so this subsection deals with the formulas and different design requirements. So all this thing will be in a general requirement. Then subsection B, fabrication requirement. So here you will see PWST requirement, welding requirement, forging requirement, material specifications. Lot of things is there in subsection C. Sorry, B. So subsection C is mainly for the heat exchanger design. You can stamp a heat exchanger as per. You can do a U stamping for a heat exchanger, but you have to follow subsection C for the design of a heat exchanger. Okay, and then we have mandatory appendix, and then we have non-mandatory appendix. So all this combined is section division 1, section 8 division 1. Okay, so let us go with the geometric limit of a pressure vessel. So you may say, for example, you are supplying a pressure vessel with the U stamp. Okay, now your client is saying, I want to connect a pipe, maybe a 1 meter long pipe from a vessel, and that 1 meter pipe I want to be included into a U stamp. Is it possible? So you have to say not possible. It is not possible. Why it is not possible? We have some limits. We have some geometrical limit for a pressure vessel. If we have not set the boundary limit, so the people will go on adding with the design. So no, that is not possible, right? So there are some geometrical scope which is limited to a section 8 division 1 design of a pressure vessel. So for welded connection, first circumferential joint. For example, you have a pipe in the pressure vessel, and you don't have a flange, or you don't have a coupling, or you don't have a nipple, but you give as a pipe, so that the client can weld on directly on a pipe on it. So that first circumferential joint on a pressure vessel, after that, it is not in the scope of a pressure vessel design. So first screw connection, same as I said, for this circumferential joint, welding joint, and the first flange joint. After the first flange joint, it doesn't carry under the section 8 division 1. For proprietary fittings, the first sealing surface. Okay. So after that, it won't be in the pressure vessel design scope. Okay. All pressure retaining covers. For example, now we have a cover. After that, it won't be in a ASME section design scope. Okay, when non-pressure parts are welded directly to pressure retaining material. Okay, so in that case, design, fabrication, testing, and material requirement applicable to non-pressure attachments. So here, what will happen? For example, you may see there are some glasses. If you have seen in a pressure vessel, you have a view glass. So the view glass is a non-pressure part, we say, but sometimes it is a non-core material also. Okay, so what we do, we have some different criteria to bring it into a pressure vessel design. But it is possible. But if you say no, I want to take that glass also into a pressure vessel design, no, it is not possible. You have to follow the different criteria. For that you have to meet your inspector, your authorized inspector AI, and he will guide you how to take it into a pressure vessel design. Okay. So if you see this picture, this is a pressure vessel. Okay, so this everything will be into a pressure vessel scope, geometrical scope. After this flange, it won't be in scope. After this flange, it won't be in scope. You can take elbow, you can take nozzle, you can take saddle, you can take this elbow in the bottom, you can take head, you can take shell. But apart from this, nothing will be falling under the ASME section 8 division 1 design scope. Okay. So detail to specify for pressure vessel. So for example, you as a client, now I am a vendor. Okay, I want to manufacture a pressure vessel, but for that design, you have to specify me something, right? You cannot say I want a pressure vessel of 10 psi design. The bus, no. You have to give lot of details to me, so that I can design a pressure vessel for your requirement. So that requirement should come from client, from a customer. So what are the requirement? So you have to take the specify corrosion allowance if one is to be applied. Okay, then vessel to be lethal service or not. So what is lethal service? If, for example, the process liquid inside the pressure vessel is having a liquid and it get leaks, so what will happen? It may cause damage to a human, or if a person breathes that process, or if it touches that liquid, and the person can have a lethal effect on his body, on his health. So that is called lethal service. For example, H2S, hydrogen sulfide gas. So if we have H2S service, we will put vessel as a lethal service. Whenever pressure vessel is given as a lethal service, in that case, you will have mandatory PWHD, you will have mandatory impact testing, you will have mandatory all weld joints as a RT1, that is full completely what we say as a radiographic joint. Okay, so all these things we will see later of the video, but I'm just saying, it is very much required for a client to say, to specify the vessel is lethal or non-lethal, or to specify application of PWST or NDE beyond code requirement. So what is beyond code requirement? So for sometime what will happen? Your pressure vessel will not come into a criteria where you have to do PWST, but your client will say no, you have to do PWST. Boss, I am ready to spend more money. So yes, you can do it. It is possible, but your customer has to specify it, you know or it is going beyond heat treatment time, or heating limit. Then also your manufacturer has to specify it, but you need to also give this concern to your AI, because he's the one person who is going to give you, authority to go ahead with the pressure vessel use stamping or not. So that case you always consult with your authorized inspector, that it is whether it is possible to have beyond code requirement PWSU and DE requirement or not. If your authorized inspector agrees, then yes, go ahead with it. If it doesn't agree, then you say customer, not possible, boss. I'm sorry. Otherwise you will be in trouble when there is an audit. If you want to renew a use stamp and there's a vessel which you have not followed the code, so your ASME can say that, sorry boss, we may not give you a further extension on your use stamp holding. It can be get cancelled. So always be very much like aware that don't go beyond code requirements. But if you're going beyond the code requirements, always consult with your authorized inspector. Identify all components to be included with the pressure vessel. Okay, what are the components included? For example, what are the head material requirements? All the components, whatever components is that, it will come as a this thing. Okay, then identify any material or fabrication requirement related to service. Okay, if there is any material requirement, fabrication requirement beyond the code or within the code, you just get it specified with the customer. Okay, so here you see the user established design or fabrication requirement including U2A. If you go to U2A and appendix NN, you will find whatever requirement is there. And normally what we give is a UDS. We take, as a manufacturer, you always take UDS from your customer or from your client. So UDS means design unified design specification. So UDS, we are talking about UDS. UDS is a user design specification, not unified design specification. I'm sorry, it is user design specification. Okay. So moving ahead, this is material requirement for the design of a pressure vessel. So material requirement means what are the material which is permitted. For example, you cannot use any material and you design a pressure vessel in section division 1. No, it is not. It is not allowed. ASME has set of different set of pressure vessel material, based on which you can only, if you want to use a pressure vessel, you have to, the material which you use in a design or fabrication has to be a ASME section at division 1 material. Okay, so if you go beyond that, the AI will not allow you to use a pressure vessel. Okay, so the material which is in subsection C in part 2, in section 2. So I will put a separate video on section 2, because section 2 is a very huge chapter in itself, because there are so much of design specifications in subsection 2. Section 2 we have 4 divisions: part A, part B, part C, and part D. So part D, what is mainly which is required for a designer, because part D has all the design details, allowable stress, the elongation factor, and all this thing will be in section part D. Okay. So then for example, if you have exception, if you want to use some material which is not in the code, but still you want to use into the fabrication of pressure vessel, it is possible. But then again, please consult your AI. You consult with him, he will guide you properly. So what is the method, where you can use a material which is not in the code library, which is apart from the code library, how you can use that material to a use stamp fabrication, uh, use stamp pressure vessel. In some case, what people do is they design pressure vessel based on ASME section division 1, but they don't use stamp it because of some limitations. Okay, but if you want to go beyond your limitations, always consult your AI, talk to him, he will guide you very properly. Okay, and non-pressure parts, such as the skirts, the internal clips, okay, the external skirt, the leg support, the saddle support, the lug support, all these things, the lifting lug, this does not fall in a section 8 division 1 design criteria, and it need not to be a code material. Okay. So okay, code design application. So code design application means code design rules are minimum requirement. If you don't follow the minimum requirement of pressure vessel design, you may not, the AI will not allow you to stamp a pressure vessel as a use stamp pressure vessel. Okay, there are a lot of requirement apart from that, which you have to take care. For example, the impact testing, the PWST requirement, the elongation factors, the radiography test, and there are a lot of things. Then hydro test is there, painting specifications. You should not paint the vessel before welding. If you do that, the AI will definitely not allow you to stamp a pressure vessel with the U stamp. A lot of factors which is there, so always follow the minimum requirement. Okay. And U2G, where the complete detail of construction are not given, the manufacturer subject to acceptance of authorized inspector shall provide the appropriate details to be used. Okay, so where some, for example, some construction part of a pressure vessel does not fall into section division 1 design. So in that case, you can consult your AI always. Ask him what to do, whether to go ahead, or all that. That is the reason why whenever you have UDS from your customer client, you always check with your AI whether we can go ahead with the U stamp or not. If it is not possible, tell your client, tell your customer, not possible, sir. We cannot stamp the pressure vessel with the U stamp, because you cannot take a risk on that. If you take a risk, you may be a problem when there is an audit. Okay, and there is one more option, where the result, it does not fall under construction of in section division 1, but then you can follow different application to still you can use them the vessel. How you can use them, where design does not exist in this division, one of the following three methods shall be used. What is 1A as mandatory appendix 46, as I said. So you can use the U2 formulas or U2 method in U1 stamp, but in that case you have to follow the mandatory appendix 46. That is possible, yes. And proof test in accordance with UG 101. If you go to, you will go to UG 101. What is UG 101? It mainly deals with the pressure testing of testing of pressure vessel. So that in accordance to that also it is possible, also for material. Okay. And other is, for example, now you want to design a pressure vessel which is square shape. So square shape pressure vessel is no, there is a no design rule or no design formulas or code where ASME section at division 1 have, you can stamp a vessel with a square shape pressure vessel. So in that case, you can apply another formula, another design standard, and you can still stamp your vessel with the U stamp, but you have to check with your AI. Okay, you can go with other standards also in that case, but in that case you have to go with your AI and tell him, boss, this is the case. Is it still possible? If your AI says yes, it is possible, you can use that standard, and you can still stamp the use stamp. Oh yes, we will go with it. Okay. So so always be aware whenever you are designing a pressure vessel, and you are not happy with the detail given by your customer. Always ask question, or go with different methods, but always consult your authorized inspector. So load conditions to be considered by designer to include, so following are the details which you have to include in your design of a pressure vessel. What are the following detail? Internal, external, and differential pressure. Internal pressure, external pressure, and differential pressure if it is there, that also you have to consider. Weight of the vessel and content. What is the requirement? Minimum, maximum requirement. Reaction from weight of attached equipment, internal support. For example, if it's a distribution column, the distribution column will have internal packing. So that packing is not part of a pressure. It is not it is a non-pressure part. It will not fall under the pressure design, but that load you need to take, right? Because that load will be considerable, to design various factors that you have to take from your customer. Cyclic and dynamic reaction. So what is cyclic dynamic reaction? For example, if you have a pressure vessel where, for example, let us take a reactor. You know what reactor in the process plant you have a reactor. Okay, in reactor what you do, you have heating and you have cooling. So you have a heating, then you give for some time, then you give cooling, then you give for some time, again you give heating. This is called cyclic loading. So in cyclic loading, what happens? The pressure vessel material tend to have fatigue inside. We as a human, we also have stress sometimes, right? When we come to home, we have a lot of stress from office. I cannot bear. So we also have cyclic load. So same pressure vessel also have some fatigue inside, which it cannot bear. If you heat and cool, again you heat, again you cool, or there is a pressure, high pressure is there, then the low pressure will come. Again after some time the high pressure comes, then pressure go to moderate level. So this is called cyclic load. This has to be considered in the design. Or if you don't consider the design, so what will happen? Your pressure vessel may fail, or it may not fail, but sometime it may fail. Okay, you will say I will go with the maximum rating of pressure vessel. So what will happen? Your cost will go very high. You may be having a thickness of 40-50 mm of a shell, but if you go with proper design, you will optimize the design and you will optimize the thickness and you will save money for you and for your client. That is also required. Then wind snow seismic loading as applicable. So the wind load, what is the wind load? What is the if it's a snowfall area? So if the snow is falling on the pressure, so what will happen? It will act as an external load. So you have to take that into consideration. Then seismic load, okay, that will come. Impact reactions such as fluid shock. For example, you may have a pressure vessel where there is a sudden change in the pressure. For example, uh, air receiver. Air receiver, what will happen? Suddenly, if your pressure goes beyond, you will have sudden pressure from the compressor. You will have a high pressure. So that shock you should take consideration into a design. Temperature gradient and differential thermal expansions. Thermal expansion you have to consider in the design. Abnormal pressure, as we discussed before also. So test pressure constituent to static head during testing. Okay. So test pressure, whatever test pressure is there, the MWP and the hydro test pressure which will come, that also you have to consider in your design. Otherwise what will happen? You have designed your pressure vessel for example 13 bar or 14 bar, okay, but your design pressure as per hydro test, as per UG 99, what we say, normally do 1.3 times of a pressure, okay, but sometimes, for example, your pressure vessel does not have capacity to bear the 30% extra. So what will happen? During test your pressure vessel will fail. So always take that into consideration. Revisit your design, recheck, reconfirm that whether it is possible or not possible, because as a designer it is very important to be on top of your design. If you miss all this small point, you may be in trouble later. Okay. So I hope you have enjoyed the video. It has gone beyond 25-30 minutes. So I will not go further in this part. I will cut short now. So there are so many factors which we'll discuss in the later part of the video. Okay, stay tuned. I hope you have liked this video. It is very informational. If you find it very informational, please like, share, and subscribe, and give me feedback. If you want to have some subject, you just tell me. Let me know if possible. I'll give you. I'll make a video on that topic also. So thank you. Stay healthy and stay tuned to my channel. Thanks a lot. Bye. Take care.